Hello students, welcome to IMS GATE Academy. In today's session, I am going to start most expected concepts of network analysis. But the subject is common for electrical, electronics and instrumentation. But the subject is having good weightage in GATE exam also now. Why the concepts are required for the students? Without concept we can't do any problem, that is assured. Suppose in the GATE examination, in the GATE paper, you are finding any question, you are unable to do that question. In that case, what you will say? The problem is very complicated. The problem is not complicated. The problem is very simple. You do not have the concept of that problem. Related concepts, whenever you know, any problem is very simple. That is why every student must have the good idea about each and every one of the concept. Yes, one of the student, Surya Prakash. Hello, good evening. Good evening. Good evening, good evening, Surya Prakash. Yes, I am going to explain, but in the network analysis, one of the points you have to understand clearly. The topics of nodal analysis and also mesh analysis and theorems and two-port network, these are all very important. They are going to play a lot of role. Even a student wants to do any question in the analog circuit, 100% it is required, the concepts of network analysis. Without knowing the concepts of network analysis, the student cannot do the questions in the analog. That's why anyhow I will give the concepts and also problems of variety I am going to do. From the different GATE papers I will select the problems and I will do here the now. Yes, in today's session I am going to put an effort on nodal analysis. So I would like to take nodal analysis in today's session. Nodal analysis. Without nodal and mesh analysis, you cannot find any GATE paper. Must. One question is a guarantee. That is why students must have the good concept on this nodal and mesh analysis. But directly I cannot enter into the nodal analysis. Nodal analysis you want to do means KCL is more important. Kirchhoff's current law is more and more important. Without knowing the KCL, we can't do any problem. That's why initially I would like to spend some time on KCL, Kirchhoff's current law, I want to use. But again, when you want to enter into the KCL, but a nodal analysis, whenever you want to apply, KCL is required. But in the node, first of all, you need to understand what is the node. Whenever certain number of branches are interconnected, thereby forming a node. How many types of nodes are there? There are two types of nodes. One is said to be simple node, second one is said to be principal node, we can say. When we can say the given node is the simple node, whenever a node is formed by the interconnection of the two branches, if two branches are combined, thereby forming the what? Simple node. More than at least three branches onwards, a node is formed means at least three branches onwards, a node is formed means we can say it as a principal node. At least three means minimum three. Three or more is required. We can define like this at first. If a node is formed, by interconnection of two branches, then it is called simple node. Simple node, I can say. Interconnection of the two branches means, suppose you have taken, this is one of the branch. Here I got one inductor like this, one more branch is formed. If these two branches are interconnected, thereby forming one node. This node we are going to call it as a simple node. This is simple node. Simple node, I can say. But what about principal node? Principal node means I can say like this. If a node is formed, by interconnection of at least, it is very important, at least three branches. At least three branches means I said minimum is a 3. 3 or more. More also you can have 3 or 4 or 5 or 6 you can have. Minimum is a 3. 3 branches. Then it is called principal node, I can say. Principal node, I can say. So how you can draw that principal nodes are? Yes, you can combine. I connected a resistor this side and one more resistor I connected. Three branches are there. By the interconnection of the three branches, a node is formed. Sir, I will take one more this side, sir. Yes, you take it. Who said no? Even you have taken one more branch this side, you can form 3 or more acceptable. I said no. This node I can call it as a principal node. I can call principal node. I can call. So in the nodal analysis, the play of principal node is more. How that will be useful, you will see while doing the problem only. Anyhow, we got idea about the what now principal node, what is the simple node I explained only now. Now we can see the next one is nothing but the KCL I want to explain. Without KCL, we can't do any question. In the KCL, just a certain number of conductors I connected like this. You take certain number of conductors and connect in such a way. There are certain number of conductors. Through certain conductors, you allow the current to pass through it. I say, I allowed current this side. That current I have taken I1. And I allowed current of I2 this side. I allowed current of I3. Through any conductor, you allow the current to pass through it. But these are all nothing but the incoming currents only now. But these are all the currents after reaching to this junction, this node point or junction. Junction is nothing but the node point only now. The net current will try to divert through the other conductors. This is I4. This is I5 I have taken here now. Here we are not going to find any current to be stayed at the junction. Whatever the current comes inside and passes through the what now? Certain number of the conductors will know. It means incoming current equal to outgoing current only. We cannot find any storing or any depletion of current at the point of the junction. That point is very important. There is a point what I wish to say. The algebraic sum of currents meeting at the point of junction is equal to 0 only. Incoming current equal to outgoing current. That law is more important. KCL says the algebraic sum of currents meeting, at the point of junction, is equal to 0, I can write it, equal to 0. That point is very important. That means summation of all the currents are made means it becomes a 0. Sigma I equal to 0, I can write directly. Summation of all the currents equal to 0. Or we can say incoming current equal to outgoing current. Incoming current equal to outgoing current. That point is very, very important. Outgoing current. But incoming current means what those currents are passing towards the direction of the node. I1 plus I2 plus I3 I can write. I can write I1 plus I2 plus I3. That equal to what I can write? I4 plus I5. I4 plus I5 is possible. This is KCL. Did you understand or not? I think students might have followed. What is that? KCL. Next one. But certain points you have to understand here now. But for what network we can apply KCL? Whenever the circuit is a lumped circuit, any network is given with a lumped elements, then only you can apply KCL. It is not the matter whether it is a linear or non-linear or time, but no, dependent or time invariant or time invariant is not the matter. But it is applicable if the network is with lumped elements only. That point is very, very important. That's why I want to give one point now. The KCL is applicable. Point number 1 I can put best. KCL is applicable. When you can applicable? The network contains lumped elements only now. Lumped elements means everybody knows now. The element which contains physical element only now. Physically visible elements are said to be lumped elements only now. Physically what they are visible? Resistor, inductor, capacitor, diode, that these all are possible now. Understand now. Anyhow, KCL is applicable for lumped. The point is very important. Lumped electric circuit. That point is very important. Lumped electric circuit I can say. But here it does not matter. I said just now, it does not matter. It does not matter. It does not matter, I can say. What is not matter now? Whether the elements are linear. Is it a linear or non-linear is not the matter. Linear. Next one, non-linear. Even you can say time variant, or time invariant, etc. Time invariant, etc. we can say. Now, what you would understand here now, if the network is with lumped elements, in that network, directly you can apply the KCL only now. Understand my point there now. And next point what you have to remember is, here whenever the current is incoming current we are finding in the networks and outgoing current is mostly possible. In that case, what you can find, there is no storage of charge, there is no depletion of the charge is possible. That means KCL is here. One point I will write now, clearly you can understand here now. Since there is no, second point, this point is very important. Since there is no there is no accumulation of charge, no accumulation of charge. We are not finding any accumulation of the charge here now. No accumulation, no depletion only now. Accumulation of charge. The KCL expresses conservation of charge. Conservation of charge only here now. Expresses conservation of charge. Conservation of charge. Because in the network you select any node, at any node, you cannot find any accumulation or any depletion of the charge only now. That is why this law, what law? KCL is expresses the conservation of charge also possible now. Understand now. And these points are very important here now. What are the rules to apply the nodal analysis? Because I am going to do the problems of many. If you want to do those problems, you need to understand what are the laws are applicable in the nodal analysis. That's where rules applicable. Rules applicable. Rules applicable. Rules applicable for nodal analysis. That is very important. What are the rules are applicable? Whenever a network is given, even the GATE or IES or any PSOC is not the matter. A problem is given. At the time, what you need to do at first, you should identify what are the nodes are existing there now. What are the principal nodes are there? What are the principal nodes are existing? Initially, you need to identify. Principal nodes are more important. Principal node means just now I said now, more than 2, 3 or more branches are interconnected. That is a principal node I said now. So point number 1, identify the number of nodes. Generally, they will take principal nodes only now. What are the number of nodes means the number of nodes are about the principal nodes who take it now. But don't bother about the simple nodes now. Understand now. And also one more point is very important. Whenever you are finding the number of nodes, one node must be taken as a reference only now. Reference means that must be grounded only now. Understand now. That's the second point we can write. Assign nodal voltage. Assign nodal voltage. Assign nodal voltage. One node you have taken, that node is some voltage with respect to reference voltage only. Reference means ground only now. With respect to nodal voltage, with respect to the ground. That is more important. That point is very important. But what about the nodal analysis means? Nodal equation, how you can form? Nodal equation, if you want to form, means KCL plus Ohm's law is more important. Without using first when a problem is given, initially you must write the nodal equation, KCL only now. Current directions you have to put now. KCL says the directions of the currents you have to put through the branches only. Second one, you must apply the Ohm's law. Whenever you apply these two, you will get the nodal equation. That is why I can write here now. Nodal equation is nothing but KCL plus Ohm's law is more important. Ohm's law. So here whenever you are applying the Ohm's law, here the temperature must be maintained constant. Even you are using the lumped elements, it is not the matter, but they must be with constant temperature only now. As we are applying the Ohm's law here now. That point is very, very important. Now we can do certain number of problems based upon these concepts only now. Understand my point now. First problem we can start. The first problem is determine, first question I want to give, determine I naught I suffix 0 in the following circuit. In the following circuit, I can say. But I want I naught value. But the network is given like this. There is 1 ohm resistor, there is a 1 ohm resistor, and also here connected with a current source. That current is given 4 amperes. This is given with 4 amperes. And this side one dependent source is connected here. Here connected with one dependent source. Direction is this side. This current is given 2 I naught. 2 I naught. It's given here now. This is connected like this. And here 8 ohm resistor is connected here. 8 ohm here connected. Here the 2 ohm resistor is connected here. This is 2 ohm resistor. And also connected with 4 ohm resistor this side. This is 4 ohm resistor. The current passing through this side is nothing but exactly small I naught means very perfect. Okay, anyhow I started I naught capital like I naught we can put. This is I naught. I'll check the numbers. 1 ohm, 4 amperes, 2 I naught, 4 ohms, 2 ohms, and 8 ohms I naught. Yes, these are given question. Thereby required I naught value. What methodology is applicable? The student should understand one point. Sir, when the nodal analysis is very easy to apply in the given problem. Whenever the network contains number of current sources you think it's so, the problem becomes very simple. Current sources, if you got more, the problem is very simple. But the current sources are not given that many, but the voltage sources and the resistors are given in the problem you think it's so. At the time it is going to take a time of the more only now. Current sources more, but don't say, sir, here I got the one is an independent source, one is a dependent source you got. Is it an easy? More number I said no. Only with a 1 and 2, we can't find that much simple only now. Anyhow, the problem is given. They're applicable only now. But how we can apply the nodal analysis? What are the nodes are existing here? You watch it now. Principal nodes. This is one of the node I want to take. I wish to select this as a node because the more than 3 branches you are having, 1 branch, 2nd branch, 3rd branch. This is one of the principal nodes. And this is also with 3 branches now. This is one more principal node. Here also 3 branches are interconnected now. I can take one more only. Each node is to be assigned with some voltage. With respect to ground only I said. With respect to ground means this is one more node is there now. That must be a reference node. With respect to ground, this must be grounded only. One is you must connect to the ground only one. Otherwise we can't get it now. But this node voltage I wish to select as a V1. This node voltage I wish to select as a V2. This node voltage I wish to select as a V3. But 3 node voltages we got. How many equations we can form here now? 3 equations we can form. By solving those 3 equations, we can get I naught only now. What I wish to say, when you selected one node, you think it's so. Direction of the current is more important. You don't get any confusion. In a simple way, I will explain now. The current direction, how I can take, sir, now. Directly you put away from the node, you take the current direction. Away from the node means the point I got now, this is one of the current. This is one more current. This is one more current. Like that we can put now. According to the what I have taken the directions, KCL is applied. Next what you have to do? Ohm's law is applicable only now. Then I can form the nodal equation. So the first equation how I can form, this current I have taken now. This current means V1 minus current across 8 ohms. V1 minus one reference 0. V1 minus 0 by 8. I can write directly V1 minus, or write V1 by directly, V1 by 8 is enough. 0 is unnecessary to put. V1 by, I can put directly. V1 by 8 plus, in this direction, directly current is given here now. What current is passing in this direction? 4 amperes plus 4, I can put directly. What current is passing this side? Current through 1 ohm. V1 minus V3, voltage across 1 ohm is nothing but V1 minus V3 by 1. I can write V1, the next equation is required. Plus I can put one more equation. Plus this current I am getting now. This current I want V1 minus V3, V1 minus V3 by 1. Summation of all the currents equal to 0 we know. Summation of all the currents equal to 0. That point is right. Catching my point now. This current is nothing but V1 by 8 I have taken. This current is nothing but the 4 amperes. This current is nothing but V1 minus V3 by 1. But I want to form an equation here now. What LCM? 8 is LCM. V1, 32, 8 V1 minus 8 V3 I can put now. That equal to 0 into 8, 0. The finally what equation I can get? 9 V1 I can get minus 8 V3, that equal to minus 32. This is equation number 1. I can note down. Did you understand? So far you followed or not? Surya Prakash, can you see? This is the first equation I formed here now. And what about the second equation? If you want to form the second equation, you take this node. Away from the node, I can put the directions of the current. This current plus, this current plus, this current equal to 0 only now. But in this case, what is I naught, sir, first of all? Because this is a dependent source only. In the dependent source, we got I naught. I naught is nothing but current across 8 ohm. I say I naught is nothing but one side I will put now. Current across 8 ohm, V1 by 8. V1 by 8. So if you know the voltage V1, directly you can compute I naught value. So our aim is nothing but to find the value of V1. If you know the V1, you can measure I naughts. That is the concept here, more important one now. Here what I wish to say, here I want to form the nodal equation now. How we can form the nodal equation? In this direction current is, we got 4 amperes. It is in reverse, minus 4. This current is nothing but V2 by 2, I can put directly. V2 by 2 I can put now. This side current is nothing but 2 I naught. That equal to 0. You watch once again. This current is minus 4. This current is V2 by 2. This current is 2 I naught. But we know very well what is I naught? V1 by 8. Directly I can substitute here now. Minus 4 plus V2 by 2 plus 2 into V1 by 8 I can put here now. That equal to 0. There I can cancel 4 times. If your 4 is the LCM, if you have taken LCM here now, 4 into 4, 16, 2 into 2, 4, 2V2 plus what I can get, V1. That equal to 0 I can get now. And finally, what equation I am getting here now, V1 plus 2V2 equal to 16 I am getting now. This is nothing but equation number 2. But I got the second equations by using the second node. But what about the third equation I can get now? What about the third equation? What about the third equation? Without doing this work, we can't get answer now. Third equation I can get by using the third, this node only now. Here I can apply this current plus, this current plus, this current equal to 0. Away from the node, you put the directions. It's a very simple. This current is nothing but oppositely it passes 2 I naught. I naught is nothing but V1 by 8. Directly I am writing now. Minus I naught is nothing but V1 by 8. 2 V1 by 8. In this direction, current is nothing but V3 minus V1 by 1. V3 minus V1 by 1 I can put, plus one more current is passing in this direction. That current I can put V3 by 4, V3 minus 0. This is the reference. With respect to ground only it is taken here now. V3 by 4 I can get here now. V3 by 4 that equal to 0. Then I want to take LCM. 4 is an LCM. 2 4s we can cancel. And what I can get? 4 is the LCM. I can get minus V1 plus 4V3 minus 4V1 plus V3 that equal to 0. And finally, what equation we can form here now? Minus 4V1 minus V1 minus 5V1 I can get. Plus 4V3 plus V3, 5V3 I can get here now. That equal to 0. 5 it is cancelled, minus V1 plus V3 equal to 0 I can get. This is equation number 3. Such a way, third equation we can form by using this equation. So, but by solving these 3 equations, the solving work is yours only now. You know very well how to solve this equation. If you are solving these 3 equations, by solving these 3 equations, you will get V1 value. Mostly this V1 will come as direct line putting now. But how to form the equation only I explained here now. You can get V1 equal to minus 32 volts it is available. Minus 32 volts it comes. If you try, if you are solving this, it's going to take some time only now. Sometimes 2 marks questions you can expect such type only now. And what about the I naught here now? I naught is calculated directly V1 by 8. The V1 by 8 is nothing but minus 32 by 8. This becomes minus 4 amperes. That much amount of the current is passing. That is I naught value. This is the methodology to apply nodal analysis to get the solution. We can do a number of problems. You will get idea. Understand now. This is one of the problem. The first problem somewhat lengthy. Next problem is reducing time. Next ones. Shall I go to the next question? Anybody? Any doubts regarding this problem? Anybody having doubt? Yes, I will give the next question. The next problem is find V open circuit voltage. Is asking to find open circuit voltage. Find VOC. OC means open circuit voltage. The network is with open circuit. That open circuit voltage is required. Sir, I am in BTech W branch in 5th semester and I had less COPS 7.8 or something. Okay, till now not came in top 10 list in our class and preparing for the GATE 2024 exam. Internally, I demotivated for semester marks. Don't bother about the marks. You don't think about the marks. You do your preparation. You do your preparation. 100% you will get the what now? Good result only now. But you think only one point. You try to get the what now? Good knowledge on the subject. Each and every one of the concepts you try to understand. Once you got a good concept, the result will come and select you. 100% that is going to select you. Don't you run back of the what now? Success. The success what now? The success is always come and select you only now. There's a good marks, you will get 100%. Whenever the preparation is a very good one. Whenever there is a sudden drawbacks in your preparation, then only it is going to be reduced only now. That's why marks of the more how to get that you don't think it. How to get the success, don't think it now. But is it possible to crack the gate or not? Don't think about this now. You think about how to gain the knowledge, how to get the concept. Are you working properly or not? If your work is a very perfect, 100% success comes. That will select you. You don't need to select the success. That will select you. Understand my point now. That only I can give. Others, that is my advice only now. Understand now? Yes, next problem. Find Now you please check now. Now you may get audio, I hope. They are setting right, I hope. Kanchan, can you say, is it audible or not audible now? Shall I start now? I think it is audible, I hope. Yes, now please watch. Thereby required open circuit voltage VOC. How we can get? We know very well this node voltage is nothing but VOC. I can write this node voltage is nothing but same voltage VOC, open circuit voltage I can say. Yes sir, very good, very good. Thereby applicable nodal analysis. To apply the nodal analysis, initially what is required? KCL is more important. KCL means direction of currents you need to put. Away from the node you can connect this current plus, this current plus, this current equal to 0. Away from the node you can connect. Then applicable Ohm's law. Ohm's law means how we can write? This current is nothing but VOC. This is the reference voltage only. Ground we can put. One is a reference, one is a ground is must. VOC minus 3, VOC minus 3 divide by R. I can put the current nodal equation. I can form this plus this current I can get this node voltage minus 2 by R. VOC minus 2 divide by R. I can put. What about the third equation? VOC minus 1. I can write like this. VOC minus 1 divided by R. That equal to 0. Summation of all the currents equal to 0 we know. I said this current is VOC minus 3 by R. This current is nothing but VOC minus 2 by R. This current is nothing but VOC minus 1 by R I have taken. Here I can cancel R terms. Directly you can cancel. And finally I can get VOC plus VOC plus VOC. I can get 3 VOC, no doubt. What constant I can get? 3 plus 2, 5, 5 plus 1, 6 equal to 6 I can write directly. Finally, what is open circuit voltage? 6 by 3. 6 by 3 equal to what? 2 voltage mostly positive. This is the solution of this question. I think you followed. I think you followed. Yes, third question I want to give in your hand. The one more question I want to give in your hand. You make an effort. And one more question is given like this. Next question. I wish to give you one more problem. Find V naught. Is asking to find V naught. Is asking to find V naught. Thereby required V naught. The network is given like this. Here connected with a current source of 8 amperes this side. Here connected with 10 ohm resistor. There is a 10 ohm resistor here. There is a 10 ohm resistor. And also connected with a 2 ohm resistor this side. This is 2 ohm resistor. And here connected one battery with a resistance of 6 ohms. This is 6 ohms. The voltage is given 16 volts. And here connected with 12 ohms. This side connected with 12 ohms. This is with 12 ohms. Is asking to find this V naught. Is asking to find this V naught. Plus minus is given. This is the problem. Can you try this question to give answer? Without my help, you please try and give answer. Please try this. 8 amperes given, 10 ohms and 2 ohms and 16 volts and 6 ohms and 12 ohms and V naught is required. But it is better to apply nodal analysis. By using nodal analysis, we can get answer very easily now. You please try. But I wish to select the node voltages like this now. Here I got one principal node. I got one principal node here. The same voltage I can have V naught because parallel connection is given here now. And this voltage is unknown. I wish to select as a V1. By using these two node voltages, I can find what is V naught. How many equations we can form? 2 equations. By solving those 2 equations, we can find the V naught value. How we can apply the nodal analysis? Initially, we need to put current direction, KCL applicable. Current direction away from the node. This current plus, this current plus, this current equal to 0. I can put directly. But this side, what current is passing? 8 amperes in reverse direction. I can write minus 8 this side. What about this current? V1 by 10. I can write directly. V1 by 10 I can write. What about this current? V1 minus V naught. V1 minus V naught divide by 2. Summation of all the currents equal to 0. You catch my point. This current is a minus 8. V1 by 10. V1 minus V naught by 2 I have taken here now. Then what is LCM here? 10 is LCM here now. 10 is LCM means I can write minus 80 here plus V1, 5V1 minus 5V0 I can get equal to 0. So V1 plus 5V1 is nothing but the 6V1 I can get minus 5V0 I can get. This is equal to 80 I can get. This I want to take it as equation number 1. By selecting the node V1, I got that equation. You form second equation. You please form one more equation. How we can form the second equation here? By selecting this node. There initially I can put the current directions. KCL I want to apply. How to put the current direction away from the node? You put no problem. This current plus, this current plus, this current equal to 0. This side current I can take V0 minus V1, V0 minus V1 by 2 I can write. The current which is passing this side is nothing but V0 minus 16, V0 minus 16 divide by 6. What about this current? V0 by 12 I can write. V0 by 12. Summation of all the currents equal to 0. Once again, I want to repeat. This current V0 minus V1 by 2. This current V0 minus 16 by 6. This current V0 by 12. What is LCM here? 12 is LCM. The 12 is LCM. 6 V0 I can get. Minus 6 V1 I can get. If the 12 is LCM, 6 2s. 2 V0 I can get here. Minus 32 I can get. Plus V0 I can get directly. Finally, the equation is written in what form? Minus 6 V1 I got here. How many V0s we got? 6, 8, 9 V0 I got. That equal to 32 I am getting. This is equation number 2. You solve those 2 equations and find the value of V0. We are getting the minus 6 V1 plus 9 V0 equal to 32. Whenever you are solving these 2 equations, you will get the V0 value. V0 is nothing but 28 volts it comes. Because V0 equal to 28 volts you will get directly. This way we can do the question. I think you followed the way of doing this question. And I want to give one more question in your hand. One gate problem I want to give in your hand. You please try this now. GATE 2023, a question was asked. I will give. GATE 2023. And the question asks in ECE branch. In ECE branch. How the problem was given, you please watch. The problem was given like this. You can type in the circuit shown below. In the circuit shown below. In the circuit shown below. The current flowing through. The current flowing. The current flowing through. The current flowing through 200 ohm resistor is 200 ohm resistor is dash milliamperes. Dash milliamperes. Round off to 2 decimal places. Round off to 2 decimal places. 2 decimal places it is given. And the network here given is, there is a 2 volts battery here. Here given 2 volts, otherwise I will draw here best. There is a 2 volts battery here connected with 2 volts battery, and 2K resistor is connected here, and this side 2K resistor is connected here. This is a 2K resistor, and also 1 milliamperes of current source is connected this side. This is 1 milliampere, current source is connected here. 1 milliamperes, and also 1K resistance is given this side. This is a 1K, and there is one current source here connected in parallel. That current source is given 1 milliampere. This is given 1 milliamperes. This is connected to 200. This is connected to 200 ohms. This is connected to 200 ohms. But he is asking, what he is asking in the problem, in the circuit shown below, the current flowing through 200 ohms required. Current passing through this 200 ohms is more important. That value we need to calculate. Values we can check 2 voltage and 2K and 2K and 1 milliampere, and also 1 milliampere, 1K and 200 ohms. Yes, that is the problem is given. Current passing through this 200 ohms is more important. The current source, whenever connected in parallel to the resistor, the source transformation we can apply. After that, we can start nodal analysis. Directly, I don't want to apply nodal analysis. First, wherever the source transformation is possible, that you complete at first. Here, the source transformation is possible, that we can do at first. 2 volts and 2K, I want to take as it is. 2 volts I connected here. This is a 2 volts here connected, and also 2K is connected here. 2K is connected, and also 2K is connected here. 2K is connected this side, and also here connected with what now? 1 milliampere is connected this side. I can connect 1 milliampere directly. 1 milliampere I can connect directly. After 1 milliampere was now 1K and 1 milliamperes in parallel here now. What I can write now? Voltage source, if you want to convert, 1 into 1. 1 volt I can get here now. I can get 1 volt battery here. 1 volt battery I can get. With what? And resistance, whatever it is connected now. 1K resistor is there now. That 1K I can connect in series. And also this side there is a resistor. That resistor is given in the problem. What is given? 200 ohms it is given. This is 200 ohms. But I want current which is passing through in this direction only now. That current I will put I, for example. I want that current. How we can measure this current? You apply the nodal analysis only now. But wherever the node, this node and this node can have the same voltage only. It doesn't have any variation now. I can put this a V. Even this voltage also same V possible here now. Understand my point now? Apply a nodal analysis. Anybody can give answer. Anybody can do this question without my help. I will wait for some time. You please try. You please try to give answer for this question. Once you know this voltage, you can measure the current easily. Current passing through 200 ohms you can measure directly. You please try at first to form the nodal equation. To form the nodal equation, you put an effort at first. Yes, I will apply here otherwise. This node voltage and this node is the same. So this current plus same voltage. These two are same points only now. We don't have any resistor in between these two. This current plus this current plus this current equal to 0 I can put directly. We got only one principal node only because these two are combined, it becomes a simple node, one node only now. That node is a principal node only possible here now. Understand my point now. How we can apply the nodal equation? V minus 2 divided by 2K. 2K means 2000 I will put directly. 2000 plus V by 2K. V divided by 2000 I can write directly. This current is a minus, it is opposite direction. Minus 1 milliampere I can write 1 by 1000. 1 milliampere I can write 1 by 1000. This current is nothing but V minus of this minus, minus of minus plus. V plus 1 divide by total resistance how much? 1000 plus 200, 1200 ohms. Summation of all the currents equal to 0, no doubt. Summation of all the currents 0. Here I can cancel 2 zeros here, 2 zeros here, 2 zeros here, 2 zeros here, I can cancel. I can cancel directly. And also I can cancel 2 6 times I can cancel. 2 5 times I can cancel. 2 10 times I can cancel. Here 2 10 times I can cancel. Such a way I can cancel here now. And you take LCM and find what is V. Take LCM and find V. What is the V you can get here now? But the LCM is nothing but 60 is the LCM, 10 6. 60 I have taken LCM. If 60 is the LCM, 10 6, 6 into V, 6 to 12. Here 10 means 6V I can get here. 5 ones 12 minus 12 I can get here now. And here I can get plus V plus 1 I can get here now. That equal to 0. On simplification, what I will get? 6V plus 6V, 12. 12 plus 1, 13V I can get. Minus 14 plus 1, minus 14. I am getting the minus 12, minus 12, minus 24. Minus 24 plus 1, minus 23 I can get here now. That equal to 0 is possible. Finally, V equal to I can get 23 by 13. I can get 23 by 13 is possible. Possible? Check it once again. 6V minus 12, 6V minus 12 plus 10V here possible. There mistake but now. 5 means here the 5V we can put here now. 5 is a 10 means 10 6, 6V I am getting now. 6 to 12 I am getting now. 6V I am getting now. Here what I can get? 5 10s. 10 into 1, 10 is possible here now. Understand now. Here I will get the 10. 5. 5 means what happened now? Minus 12 here possible. This is a minus 12, sorry. This becomes a minus 12, 100% perfect. We are getting the minus 12. Finally, here now 6 into 10, is it not? Not 10V is available here now. Here 10V. Yes, I'll complete. I'll complete. I can get here now 10V plus 10 I can get now, because 60 is the LCM here now. But whenever you are simplifying this one, you can get directly here now. Whenever you simplify this, we can get here now. How we can simplify this value? This value I can get like this now. But finally, what I can get here now, 6 into 10, 0, 6V, 12, 12V, 12 plus 2, 22V I can get here now. Minus 24 plus 10, minus 24 means 10 if it is removed, minus 14 is mostly possible, I think, minus 14, that equal to 0. And finally, V equal to what is possible, 14 by 22 I can get now. 2 7s I can cancel, 2 11s is possible now. That much value is possible. That much value is possible. So 7 by 11 volts mostly it is possible. 7 by 11 volts here possible. 7 by 11 volts are possible. Once you are getting the voltage V, you think it's so. You can measure what is I. I can be calculated by current passing through this side. V minus of minus plus V plus how much? 1 divided by total resistance. Total is nothing but 1200 only here now. But I can write V is nothing but 7 by 11 plus 1 by 1200 I can put now. 1200 mostly possible. If you are using the calculator, that value will be 1.36 milliamperes possible. 1.36 milliamperes of current you can get now. Such a way we can tackle this question here now. That is the methodology. And I wish to give one more GATE question. GATE 2022 ECE paper given. I wish to give one more GATE question. The one more GATE problem I want to give in your hand. This is given very simple. GATE 2022. This question asked in ECE paper. GATE 2022. By using the nodal only. I will not apply any other method today. The current I, question is given like this. The current I is asking to measure the current I. In the circuit shown is, dash is given, and the network is given like this. 2K resistor is connected here, and there is a supply 5 volts. One battery voltage is given 5 volts, and here connected with the 2K resistor, there is a resistance of 2K, and also connected with the 2K resistance this side, one more 2K, and this is connected to the what? One current source, 10 power minus 3 amperes. Current direction this side, 10 power minus 3 amperes it is connected. Yes, he is putting the direction this side. He is asking to measure this current I. This is one of the GATE problem. GATE 2022 ECE paper. Anybody can complete. But a number of branches are interconnected. How many? 3 branches now. So it becomes a principal node. We need to consider only a principal node only now. You apply, you can apply. How we can do this question? This node voltage I can select. I can select this node voltage as V. Once I know the voltage V, I can measure I. I is nothing but current across 2K. How to get current across 2K? 5 minus V by 2K. I will get I directly. But how the nodal is applicable, the current direction is a must. This current plus, this current plus, this current equal to 0. But I can form the nodal equation. V minus 5, solution I want to take here. V minus 5 by 2K. 2K is nothing but 2000, I will put directly. Plus, this current is nothing but V by 2K. V by 2000 I can put. And this current in the reverse direction, 10 power minus 3 means reverse, minus 1 by 1000. 1 by 1000 I have taken. Summation of all the currents equal to 0, you know very well, as per the nodal. Thereby cancel 3 zeros, 3 zeros and 3 zeros. LCM is nothing but 2. If 2 is the LCM, what I can get? V minus 5, this side plus V minus 2 I can get here now. That equal to 0. V plus V, 2V. That equal to 7. V equal to how much? 7 by 2. This is nothing but 3.5 voltage I am going to get. I am getting 3.5 voltage only. That voltage is a 3.5. Once you got this voltage, you can measure what you can get. I is required. Current across 2K is required. That is I. What current is passing across 2K? 5 minus V. 5 minus V divided by 2K. 2K is nothing but 2000. 5 minus V is nothing but 3.5. Divide by 2000. 5 minus 3.5, 1.5 by 2000. 2K, no problem. But what is the answer here now? 0.75 milliamperes. 0.75 milliamperes of current is passing. 0.75 milliamperes of current is passing this side. That is the solution for this question. It's a GATE 2022 in ECE paper asked. In GATE 2022 in ECE paper, one more question is asked that I want to give in your hand. You please try this now. But one more problem is given like this in the GATE paper. GATE 2022 in ECE paper, this question was asked. I would like to give in your hand. You please try this question and give answer. Consider the circuit. Consider the circuit. Consider the circuit. Consider the circuit shown in the figure. Shown in the figure. Shown in the figure. Shown in the figure. The current flowing through 10 ohm, the current I flowing, the current I, that is denoted by symbol I, flowing through, current flowing through the 10 ohm resistor is, the 10 ohm resistor is 10 ohm resistor is 10 ohm resistor is dash. And here the network is given like this. 3 volts here connected. There is a battery, or there is a voltage here connected with 1 ohm resistor, and here connected with 2 ohm resistance or resistor, and this is connected to the ground. The problem it is given. Here the 10 ohm resistor is connected here. But we want the current passing through this 10 ohm, that is I here given. And also here given 1 ohm resistor. This is 1 ohm. And this side connected with 2 ohm resistance. And this side connected with 3 volts. Three volts here connected. Yes, this is the given problem. This is the given problem only. But what current is passing across 10 ohm? Anybody can give answer? Anybody can give answer for this question? But we can say directly the no current is going to flow through 10 ohm resistor because it is not a closed circuit. This is not a closed circuit. If any current is passing this side, means same current must pass this side only now. It is not satisfying properly. That means this side we cannot find any current because it is not a closed circuit here now. Whenever it is not a closed circuit, that whatever the current is passing this side, it will flow this direction only now. It doesn't divert this side. Whenever no current is diverting across 10 ohms, current across 10 ohm equal to 0 we can put directly. So answer is current through 10 ohm equal to 0 amperes only. It is possible because it is a open circuit only. In the open circuit we cannot find any current only here now. Understand? That is the solution of this question. That is answer. And one problem I want to give in your hand. You please try. If you are getting answer, very good. You can try this question without my help. In ECE paper in 2021, a question was asked. I would like to give in your hand. You practice this question. The same model you apply and try to get answer. I want to give in your hand. The ECE paper, it is given in ECE paper 2021. The same nodal you can apply. Consider the circuit shown in figure, the circuit shown in figure. The value of V naught is dash. Some voltage you will get now. The network here given like this. 4 volts here connected. This is connected with 1K resistor. And here connected with 1K resistor. This is 1K. The voltage across 1K is given here V naught. Plus this V naught is asking to find. Here 1K is connected here. And this side current source 2 milliamperes here connected. 2 milliamperes of current is passing this side. And also connected one current source 6 milliamperes this side. This direction, this side, 6 milliamperes. 4 volts, 1K, 1K, and 1K, and 2 milliamperes, and 6 milliamperes. Yes, that is the given problem. But thereby asking to find this V naught. You please try. If you are getting answer, very good. Because you followed the concept, what I explained in today's class. If you are unable to do, once again you watch this video and get the concepts clearly now. Thank you. We can close it there.